All right, hello. So, as I mentioned yesterday, we are going to be taking notes just as if I were there. I am going to ask for a little patience and a little bit of grace because I cannot find my stylus. So, I'm going to have to draw with my finger, and it's probably going to be a little sloppy, just warning you. Another thing to just kick this off right off the bat, I do have a typo in here. That is not supposed to say same side. That is supposed to be alternate interior. So we're going to start off with a little bit of a review of what we talked about yesterday. So we talked about yesterday, we have parallel lines cut by a transversal, and we've got these 8 angles. And when you have these 8 angles, we have these different angle relationships, which is what we're going to talk about here. Now what we're going to find out today is that we have these parallel lines cut by a transversal. These angle pairs, certain angle pairs are congruent while others are supplementary. And I've got this chart up here for you so we can list out which angles are congruent and which are supplementary. So you can see here from the chart, kind of a little spoiler alert, the alternate interior angles, these are going to be your congruent angles. So as a reminder, the alternate interior angles are going to be the angles on alternate sides of the transversal. Now you have to remember that you have to take one angle from one intersection and the other angle from the different intersection. So for example, if I were to take angle 1, so angle 1 is an interior angle. So if I were to find the pair that goes with angle 1 for the alternate interior angle, I need to hop across the transversal and go to the other intersection, but stay on the interior. So this is going to be angle 1 and angle 7. We have a theorem that says if parallel lines are cut by a transversal, then alternate interior angles are congruent. So we know that angle 1 is congruent to angle 7. Now we would also know there's another set of alternate interior angles, that is angle 6 and angle 4. So those are also congruent, angle 6 and angle 4. Now what's cool here is that we also have alternate exterior angles. These are also going to be congruent. So for example, if I were to take an exterior angle like angle 3, the angle that goes with angle 3, since it's alternate, we're going to hop across the transversal and go down to the other intersection, but stay on the exterior. So it's going to be here at angle 5. So the alternate exterior angles are going to be angle 3, congruent to angle 5. And we have another set of alternate exterior angles as well. It's going to be that angle 2. Notice it's on the exterior as well. And angle 8. So angle 2 is going to be congruent to angle 8 because of the alternate exterior angles theorem. Okay, we also have these sets of corresponding angles. Now, when we talked about these yesterday, I had told you that these are the angles that are in the same location, just a different intersection. So, for example, if I look at angle 2 is in the top left-hand corner of that intersection. So if I go to the other intersection, I would need the top left-hand angle, which is angle 6. And it won't let me draw it. There we go, angle 6. So we have angle 2, and I'm going to not write the angle symbol because it's easier for me, but please write the angle symbol. So angle 2, congruent to angle 6. If I go to the bottom left angles at each intersection, that would be 1 and 5. So angle 1 is congruent to angle 5. If we go to the bottom right hand angle at each intersection, that would be 4 and 8. So we'd have angle 4 congruent to angle 8. I know this is very messy. You're going to have to make sure we're listening. And then finally, that last set of corresponding angles would be 3 and 7. So angles 3 and angles 7. Okay, now the last angle relationship that we have are these same side interior angles. Now, same side interior angles are not congruent, but they are going to be supplementary. So I'm not going to use that arc because that arc means congruent. So what I'm going to do instead is I'm going to use just a little dot. I'm going to show a dot here at 4 and a dot here at 7. What that means is that angle 4 and angle 7 are supplementary. So if I take angle 4 plus angle 7 and add those together, it should give me 180. I could do the same thing here with angle 1 and angle 6. Maybe I show 2 dots there. So if I take the measure of angle 1 plus the measure of angle 6, I should get 180. All right, so those are our angle relationships. Most of them are congruent. We just have to make sure we keep these separate. What we're going to be doing today is we are going to be applying these theorems, applying these properties to be able to solve some problems. Okay, so I'm really going to need some grace here as I try to work these out. So if there's math to work out, I'm probably going to work it out over here on the right-hand side where you can just work it out there on your notes. Now the first ones, there really shouldn't be a whole lot of work that we need to do because it's just identifying what the angle relationship is and then using it to help us find the angle measure. So if I look at this first example here, I have these 2 angles. I've got my transversal. We talked about this yesterday. If I look at those 2 angles, they're on the same side of the transversal. So they're not alternate, they are same side. Now if they're same side, they could be same side interior, they could be same side exterior, or they could be corresponding. Now if I look at the same side interior, the missing angle is interior, but that 128 is exterior. So they are not same side interior or exterior. What these ones are going to be is, if you look at them, they're both on the bottom left-hand corner of the intersection. So these are going to be corresponding angles. So if we hop back over to that left-hand side, if you notice, the relationship between corresponding angles, they are going to be congruent. So if this angle is 128, this angle is also going to be 128. Now if we look at this next one, okay, if I look at, I've got these 2 angles, I've got my unknown angle and I've got this angle that is 97. If we look at our transversal here, okay, these angles are also on the same side of the transversal, but this time they are on the interior of those parallel lines. So we're looking for same side interior angles, and what my theorem tells me is that same side interior angles are supplementary. So if I add these 2 angles together, I should get 180. Well, if I know one of them is 97, to find the other one, I can take 180 minus 97, and my missing angle is 83. There's your answer. Okay, this one down here, if we try to classify these angles, we've got our transversal here. If you notice here, I'm hopping across that transversal. Okay, hopping across, so these are going to be alternate angles. And if we look specifically, they are on the exterior of those parallel lines. Notice here's your parallel lines. They're outside on that exterior of those parallel lines. So these are going to be alternate exterior angles. And once again, looking back at our little chart, those alternate exterior angles, those are going to be congruent angles. So 96, if that angle is 96, this missing angle is also going to be 96. All right, and then this final one here, if we look at our transversal, we look at our parallel lines. These angles are also alternate angles. Notice you're hopping across that transversal, but this time these angles are on the interior of those parallel lines. So we have alternate interior angles, which notice those are also congruent. So if this angle is 100, this angle is also 100. Now the other thing that we can do is we can use these properties to solve an equation involving these angles. So if I look here at this example, and I'm just going to do my work over here on the right hand side, we kind of have to go through the same process where I have to look at these angles and I've got to classify them and know what the relationship is. So on that first one here, if I look at that 23x plus 5 and the 24x, they're on the same side of the transversal, but one's interior, one's exterior, but if I look closer, they are both at the top right-hand corner of the intersection. So when they're in the same location, but at a different intersection, these are corresponding angles. And referring back to our little chart here, corresponding angles are congruent. So remember, if I have congruent angles, that means that their measures are equal. So what we're going to do here is we're going to take that 23x plus 5, and we're going to set it equal to 24x. And then we can use this equation to solve for x. I have variables on both sides of my equal sign. So if I subtract 23x from both sides, we would get a 5 equals, and then this is a pretty simple equation to solve because 24x minus 23x just gives me x.